Beneath the shimmering blue skin of our planet lies a world so vast, so alien, and so unexplored that it might as well be another planet entirely. More than 70% of Earth's surface is covered by ocean, yet nearly 95% of it remains unexplored. While humanity has mapped the surfaces of Mars and the Moon in astonishing detail, the depths of our own planet's seas remain shrouded in darkness, mystery, and pressure, so crushing it can turn metal into mush. This is not just an oversight, it's one of the last great frontiers of human discovery. The question is no longer if we should explore it, but how. The ocean has always been both a giver of life and a keeper of secrets. It regulates our climate, generates most of the oxygen we breathe, and shapes the weather patterns that sustain our planet. Yet, for all its importance, we've barely scratched the surface of what lies beneath. Only about a quarter of the global seafloor has been mapped with high-resolution sonar. The rest remains a vast, featureless void on our maps. A black expanse that hides mountains taller than Everest, trenches deeper than the Grand Canyon, and ecosystems so bizarre they seem to defy the laws of biology. Why then, in an age when we can send probes to Pluto, does so much of our own ocean remain a mystery? The answer lies in the ocean's hostility. Light fades just a few hundred meters below the surface. Temperatures plummet to near freezing, and pressure builds to over 1,000 times what we feel on land. Every 4 meters down adds another atmosphere of pressure, meaning that at the depths of the Mariana Trench, the force on every square inch is equivalent to a small car sitting on your fingertip. Exploring such an environment is an engineering nightmare where a single flaw can mean total disaster. Yet the rewards are immense. In the last few decades, each deep-sea expedition has rewritten our understanding of the planet. In 1977, scientists exploring the Galapagos Rift stumbled upon hydrothermal vents spewing scalding mineral-rich water, surrounded by an entire ecosystem thriving without sunlight. It was the first time we found life that didn't depend on photosynthesis, a revelation that expanded our concept of where life could exist, even beyond Earth. Since then, expeditions have discovered glowing jellyfish, transparent squid, fish with glass heads, and ancient coral forests untouched for thousands of years. These aren't just oddities. They're living evidence that our world is more complex and resilient than we ever imagined. To explore this hidden world, scientists have had to become equal parts engineer, adventurer, and artist. Mapping begins with sonar, a technology that sends sound waves down to the seafloor and measures how long they take to bounce back. The result is a rough image of the landscape: mountains, valleys, canyons, and plains that no human eye has ever seen. Projects like Seabed 2030 are racing to chart every inch of the ocean floor by the end of this decade. But with less than 30% completed, the clock is ticking. Then come the explorers of the deep, the machines that dare to descend into the abyss. Remotely operated vehicles, or ROVs, act as our eyes and hands in the deep ocean. They can dive thousands of meters below, filming alien-like creatures and collecting samples from the seafloor. Manned submersibles, though rarer, offer something even more extraordinary: the ability for humans to look out into that black expanse with their own eyes. When filmmaker James Cameron descended nearly 7 miles into the Mariana Trench in 2012, he described it as entering a completely different world: silent, lonely, and infinitely strange. Autonomous underwater vehicles, or AUVs, are the new pioneers. Unlike ROVs, they roam freely without human control, gliding through the darkness for hours or even days, collecting data on temperature, salinity, and currents. These robotic explorers, guided by artificial intelligence, are helping scientists study vast regions that would otherwise take decades to cover. And above it all, satellites scan the ocean surface, measuring subtle variations in gravity to infer what lies beneath. The technology is breathtaking, but even with it, the sheer scale of the ocean makes progress agonizingly slow. Each mission is a balancing act of innovation and endurance. Saltwater corrodes metal, pressure destroys electronics, and communication through miles of water is nearly impossible. Sending a signal to a deep-sea robot is like whispering through concrete. Scientists have to rely on acoustic communication, which is slow and limited. Data transfer takes hours, sometimes days, and every malfunction means losing millions of dollars of equipment to the deep. Still, they persist, driven by the belief that the answers lying below are worth every risk. And those answers are crucial. The deep ocean is not just a mysterious wilderness, it has a fundamental part of Earth's life support system. It absorbs over 90% of the heat trapped by greenhouse gases, making it a massive climate regulator. It stores vast amounts of carbon, helping to buffer the atmosphere from the worst effects of human pollution. Without the ocean's unseen work, Earth's climate would spiral out of control. Yet, without understanding how the deep ocean functions, we can't predict how it will respond to a warming planet. Beyond climate, the deep ocean is also a treasure trove of biodiversity and potential resources. Scientists estimate that there may be millions of species yet to be discovered, many of them microscopic, living in extreme conditions that could hold the key to new medicines or biotechnologies. At the same time, the seafloor hides deposits of precious minerals like cobalt, nickel, and rare earth elements, vital components for renewable energy technologies. As interest in deep-sea mining grows, the race to explore is also becoming a race to protect. Once damaged, deep-sea ecosystems may take centuries to recover, if they recover at all. This makes exploration not just an act of curiosity, but of responsibility. The more we know, the better equipped we are to manage and safeguard this immense, fragile system. Every map, every sample, every pixel of sonar data helps build a clearer picture of how our planet really works. Subscribe for more explorations into Earth's hidden frontiers, and tell us in the comments, if you could explore one part of the deep ocean, where would you go first?